Have you ever responded to any email which contained any promotional offer? Chances are you might have clicked on the link if the offer looked very promising, as it might have contained a heavy discount on the product you were longing for. Examples are maybe a mobile phone, a gaming console, LED TV, etc. Right? So you then might have moved ahead with purchasing that product, or may not be. If that offer was not promising, then you might just have ignored the email. Folks, Nitin here, and this is the AI University channel. In this video and onwards, we are going to develop various models which can predict the target variable, which is categorical in nature. That is, in our above scenario, the response could be categorical, like either the customer is going to click on the email offer, or he or she is not going to click on the email offer at all. So building a model to predict the action a customer is going to take based on various independent variables. This is the part 1 of introductory video where I am going to cover the intuition behind logistic regression. So watch this video till the end to set the foundation in classification family of algorithms. And logistic regression would be the first algorithm in that family. If you are new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about hottest technologies of 21st century. So the family of algorithms which model the probability of a certain class or event existing, such as spam, not spam, pass or fail, win or lose, yes or no, click or not click, etc. are called as classification family of algorithms. Logistic regression or logit regression is one such algorithm. So let me show you a diagram real quick first. So based on example I quoted earlier for email response, we got the scatter plot something like this, where on the x-axis we have income as independent variable and clicked offer yes no as dependent variable. We can see that less number of data points are lying at y equals to 1 for income ranging from 10,000 to 50,000, and most of the data points are lying at y equals to 1 beyond 50,000, that is the income beyond 50,000. Please note that y equals to 1 here represents that a customer has clicked on the email offer, and y equals to 0 means he or she has not clicked on the email offer. You can also see that there are certain data points on y equals to 0 as well. So what does that signify? Well, it means that offer was more lucrative and promising for people who has income in the range 50,000 to 120,000. It may be some expensive item like diamond ring, etc., on which they were getting heavy discounts. So you can see that data points are either lying on y equals to 0 or y equals to 1. So it is very difficult to build a model for such problem with the help of a linear regression model, because the best fit line will not touch these data points very efficiently, as the data points are lying at extreme ends, that is y equals to 0 and y equals to 1. So what we essentially do in such scenarios are that we predict the probability or likelihood of that customer going to take any action for a particular event or offer or not. Let's say you want to fit the best fit line using linear regression, and this line is crossing the horizontal line at x at 20,000 and upper bound horizontal line at x equals to 85,000. So for any customer who is falling income between 20,000 and 85,000, the probability of clicking on email offer is increasing as we move to the right. While it's totally okay to have probability value for this region shown in the circle, but what about data points or observations above y equals to 1 and data points below y equals to 0? The reason I'm asking this question is that you can't have probability values greater than 1 and less than 0. What we could also interpret from this best fit line is that people above income 85,000 are very likely to click on the email offer, And people having income less than 20,000 are not at all going to click on the email offer. So basically this linear regression line would then be represented like this. In a nutshell, clipping off the portion of the line above y equals to 1 and below y equals to 0, and then merging those portions of the line into horizontal lines at y equals to 0 and y equals to 1, thereby trying to create a model for this kind of problem. This way we can try to make predictions of clicked on or not clicked on email offer based on income. So now let's take a look at more scientific approach. So we started off with this regression line, and we already know that corresponding equation of regression line looks like this, which is highlighted here in orange. Then we turned this regression line into sigmoid kind function graph by clipping off extreme end lines and then merging them to horizontal lines. So the corresponding equation of such sigmoid function line would become like this. Now put the value of y equals to a0 plus a1x into sigmoid function highlighted here in blue. When you solve the sigmoid function for y, you will get y equals to natural log and in brackets p upon 1 minus p. Now substitute this value of y back into the equation of regression line. Your equation would become natural log and in brackets p divided by 1 minus p equals to a0 plus a1 multiplied by x, which is highlighted in the green. So this is what represents logistic regression. The corresponding chart of this logistic regression equation would look something like this. So basically this line of logistic regression is the best fit line which can fit the data points shown in the chart, and we are trying to get this best fit line using logistic regression. We can treat this line as our logistic regression model, which is ready to predict the probability values for dependent or target variables. These probability values lies in between 0 and 1. So folks, this is it for this video. In the next upcoming video, I will be covering remaining portion and part 2 of this video. So here is today's question. If the value of y is 1, then will our customer going to click on email offer or not? Please post your answers, comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.